Welcome friends, in this one, let f be the function given by f of x equals ln of 3 minus x. The third degree Taylor polynomial for f about x equals 2 is this following. Okay, I'm moving myself this way because I kind of use it as a focus point when I read. So, let's answer this question. This is from the 1997 AP Calculus BC test, multiple choice section. You have here f of x defined as ln of 3 minus x. From there, you're going to have the following. You need to form f prime of x, so it's going to be here 1 over 3 minus x times the derivative of that 3 minus x, which then would be the following. At first, negative 1 from differentiating 3 minus x over negative x plus 3. Write it this way. Then factor negative 1 from each term in the bottom, so it becomes negative 1, and it's negative 1, and then x minus 3. Cancel off the negative 1s, leaving a positive 1 in the numerator, so it's 1 over x minus 3. F double prime of x, that, remember, would be formed by differentiating the first derivative, which I will write here as x minus 3 to the negative first. Power rule, chain rule, that if you wanted to use it, you'd have negative 1 and then x minus 3 raised to the negative second. Officially, you should differentiate by, multiply by the derivative of the inside, but the derivative of x is just 1, doesn't change anything. So you just end up, in other words, with negative 1 over x minus 3, this quantity is squared. We have to focus like a laser beam here. F triple prime of x is then equal to the following. The derivative with respect to x of, pull that negative 1 outside from the previous derivative, so it doesn't clutter the picture. That's x minus 3 here to the negative second. Okay, focus. Negative 1. Now, that would be the following. Negative 2, and then x minus 3 gets copied. This would be negative 2 minus 1, negative 3, which is then 2 over and x minus 3 raised to the positive third this way. These are our derivatives. And then from here, I would have the following. F of 2, well, that's just ln of 3 minus 2, which is the ln of 1, which is 0. F prime of 2, that's, let's see, it's 1 over 2 minus 3, which is negative 1. 2 minus 3 is negative 1, so 1 divided by negative 1 is negative 1. F double prime of 2, focus like a laser beam. Negative 1 here over, and then 2 minus 3 squared, so it's going to be negative 1. 2 minus 3 is negative 1. Negative 1 squared is positive 1. Therefore, negative 1 is what comes out. F triple prime of 2 here is, let's see, it's going to be 2 over 2 minus 3 quantity cubed this time. It's going to be 2 over, let's see, oh boy, negative 1 cubed, and then this is going to be here 2 over negative 1, which is then a negative 2. Put the pieces together according to the Taylor formula. So we're going to have the following then. F of x is approximately equal to, now, the constant is 0, so you don't have to include it. That means you're going to put negative 1 over 1 factorial. That doesn't change anything, it's just negative 1. Then you put your term x minus 2, because remember, it's expanded at x equals positive 2. And then this is basically to the first, but nobody puts that as to the first. We're just going to ignore it. The next one would be plus the second derivative evaluated at positive 2 over 2 factorial. But the second derivative value is just negative 1, so that overrides the positive. And then you would have 2 factorial, which is just 2, and then you would have here x minus 2 quantity squared. And the last one there would be the following. The third derivative evaluated at 2, which is negative 2. That would override the positive from the formula. And that would be over 3 factorial, and then this here would be x minus 2 cubed. Remember that 3 factorial is 3 times 2 times 1, which is 6. 2 6 reduced becomes 1 third. That is the answer. Which means that the correct answer, in other words, is B. This is the only one that has all of the signs correct. Alright, friends, I know we banged this out super fast, but I hope it's been helpful to you. Please leave a like, please subscribe. Thank you so much for watching. I will see you in another